Good morning, everybody. How are you? All right, energy. I like it. I'm gonna have to draw some energy from you guys. All right, this gonna work? Ta-da! All right. As advertised, I represent what we are calling the Computer Science for All movement. Who here has heard of Computer Science for All? All right, woo! Not as many as I thought, but when you leave today, you will all be able to say yes affirmatively that you've heard of Computer Science for All. I want to start off by thanking this community, which I've known about for a number of years through friends who have attended this conference. And I want to thank Jesse, G. Davis, and Dan Crosta, who invited me to do this and helped me get started. I've heard that this is a special community convening of people from my friend Jonah, who's here. He assured me that you're humble, creative, and committed to education. And so if that's true, this is definitely a place that I'm excited to be. I lead this organization, NYC. We're the New York City Foundation for Computer Science Education. We're 4 years old. We are a nonprofit organization that was started, as Paul said, to bring computer science to every single public school student in the city. That is an audacious goal. We have more than 1 million students in the school system here. How many folks in the room went to a New York City public school? All right, maybe 10, 15, 20%. Great. And if you went to a public school in the city and you had computer science, and you're an adult, that means you're in a very small minority. So when we started our work, computer science was really available in maybe 5% of schools citywide. And so the challenge was to figure out in what form we could bring computer science to all kids and what it would look like, how we would do it, how we would ensure that it would be high quality. And I'm pleased to say 2 years ago, we announced a partnership with the city called Computer Science for All. So now you've all heard of Computer Science for All. That is an $80 million program that we split public and private costs with the city to operationalize this idea, which I'll talk about in a little bit. So this is going well, and I'm also going to share a bit about how this kind of movement is taking root nationally and what it looks like. It's actually a really, okay, so here's the logo for the New York City Initiative, Computer Science for All. And I'm also going to talk about this national work. It's really exciting in our field right now. Computer science has been around as a field for decades, but the K-12 side has kind of come and gone with different periods of boom and bust, as it were. I want to say more about why that might be as well. I've been working in education technology for my whole career. It started in the New York City public school system right when the internet arrived in schools. Nobody really had any idea what to do with it. There were little blocks of 4 computers in the back of classrooms and then a web connection and websites that looked like this. And you could argue that people still don't really know what to do with the internet in classrooms. In reality, though, practices have improved significantly over the years, and nowadays you hear things like personalized learning and portfolios and project-based learning that really activates kids and gives them a lot of tools and agency to do things that are creative and fun and interesting. Computer science is not ed tech. It's not digital literacy. It has elements of these things. In some ways, the computer science movement is enabled by the infrastructure and the changes that have been made over the last couple of decades, including things like more ubiquitous devices, cheaper, more plentiful stuff, improved broadband infrastructure, and Wi-Fi. So these things are all important. But to me, what is most compelling about computer science is that it really fundamentally changes the experience of students and teachers in the classroom. With ed tech, that's not always the case. Sometimes ed tech is efficiency, it's engagement, it's information, but computer science actually really changes what students do and what they learn. So I thought I would take a step back. All of you understand something. If you're in the room right now, you understanding about something about computer science. In fact, you may be a developer. I assume that's the case for most of you here. And you probably had a whole wide range of inroads to that world. But I thought maybe just for the sake of kind of level setting, I would talk about kind of where K-12 computer science came from. The AP exam was introduced in 1985. How many folks took the AP computer science exam in high school? All right, small number. 10%. And that language has changed a lot over the years. It was BASIC when it was first introduced. It became Pascal. It's now currently the Java exam. It's dictated by, one day it will be Python. It's really dictated by what the colleges want to see. But what was actually taught in classrooms was kind of the Wild West. It was based on typically a given language that the teacher was comfortable with or a specific curriculum. There's a whole lot more curriculum now. The last 5 years have seen a huge explosion of curriculum. And if you go to computer science classrooms in New York and elsewhere, you see all kinds of different stuff happening. Some folks, I think, given the number of folks here who said that they took the AP exam, I'm assuming that you came into computer science through all different pathways, whether it was through school. My personal first experiences were in elementary when we had a logo in our classroom. And then also my father gave me a book on BASIC and said, go figure this out. So a lot of people come into the world that way. However, that implies a certain privilege and access that is not the norm. And for us in New York City, that meant that a whole lot of kids were being left out. So back to the idea of definitions. Let's take a step back. Here's a definition I like. Conveniently, there's a CSEd discussion forum on Facebook, and someone recently took a poll of favorite definitions of computer science for humans. And this is Brian Dorn's a professor at University of Nebraska. He says it's the study of computers and algorithmic processes, how they work, et cetera, what they can and can't do. What I like about this especially is there's a suggestion that computers can be deployed to solve problems, but they also have limitations. I think the fact that they can be used for problem solving, I think, is super compelling to a lot of kids and something worth highlighting. And also being aware of the impacts. We'll come back to that topic. My colleague at CSNYC, named Leanne DeLizer, likes to cite this definition from Herbert Simon, who is a professor at Carnegie Mellon, among other things. And he said it's the study of computers and all the phenomena that arise around them. And to me, that's exciting because the phenomena part kind of allows you to expand the edges a bit to include things like HCI and design, as well as things like privacy and social impacts. So gradually you see where we're kind of broadening our definition here. Last year was the culmination of a long process of writing a K-12 CS framework, which is at k12cs.org. Co.org led this community-based writing effort and created what has now become the standard for states and districts who are trying to wrap their heads around what is K-12 computer science. And this is very important. This is the first really modern statement of what might be taught in K-12 schools. And it's broken down into concepts and practices, as you can see here. And you notice that algorithms and programming are just one of the 5 major concepts that are covered. I also think it's very notable that practices includes fostering an inclusive culture, which is important, and also communicating about computing. That it's not just people. I think the public has a sense of computer science as something that you do in isolation on a machine, and it does not necessarily involve these other things. Lastly, I want to land at New York City. So I mentioned that we're now a couple of years into this 10-year initiative with the New York City Department of Education, and they released a blueprint this summer that is meant to be a communication to the school system. What's computer science? What are you going to try and do? How we're going to help you do it? This is a massive undertaking to get 1,500 plus schools to start teaching computer science when there's no teacher in the building and no place in the schedule for it. So there's a lot of learning and a lot of problem solving things that are happening there. What I like about this particular definition, if you go to blueprint.CSforAll with a number 4.NYC, you can read all about this. But it really embraces creativity and agency for kids and in balance with those real world issues of how to make this fit within a school building. It's not just about teaching fundamentals, but giving kids, empowering kids and their teachers. I think it's very important to realize that in most cases, teachers are learners here as well, that they're not coming from a CS background, really. It also tries to get to the why, like why this matters. So it's 2017. There's a CSforAll movement happening in New York City, and it's also happening all over the country. So I mentioned in 2015, we launched New York City's 10-year initiative. It's going well. Don't tell anybody, but there are tens of thousands of kids studying computer science in their classrooms currently in the New York City school system. I think that has huge implications for years from now when these kids come up from K-12, go to college, go into careers. They're going to look like New York City kids. New York City is a highly diverse school district. You can go on the web. I probably should have had a slide that explained what that diversity looked like, but if it's, it's half boys and half girls, it's Black and Latino, Asian, white, it's everybody. CS4All happens in Chicago. Chicago has an initiative like this. It's also in other cities, and everybody has a logo. The number that we use the number 4 as for the 4 in New York City, and FOR for kind of the blanket statement and the hashtag. So why now? Why is this happening now, and why didn't this happen 10 years ago or 15 years ago when we had the first internet bubble, for example? And I think the answer is it's similar to that adage that it's an overnight sensation 10 years in the making. This is kind of I have a 15-year-ish timeline here that this might be somewhat arcane for those of you, and it is definitely acronym fantasy land here, but there are a lot of amazing efforts that have been going on quietly all over the country for years, many of them funded by the National Science Foundation. A woman named Jan Cuny there has been the driver of a lot of this work. NCWIT, the National Center for Women in Information Technology. ESEP is a statewide coalition exploring computer science. ECS is an amazing introductory course out of UCLA. Bootstrap from Brown is a mathematics and computer science integration curriculum. Project GUTS is science. There's a brand new APCS principles course that was offered officially for the first time this year, and about 50,000 kids nationally took this exam. It's the biggest launch of an AP exam ever. CS Ed Week. Does anyone know what Computer Science Ed Week is? Very few, all right. So I'm gonna leave you guys knowing so much more about this stuff today. Computer Science Education Week is roughly the second week of December every year. It's scheduled around Grace Hopper's birthday. If you don't know who Grace Hopper is, you should look that up. So it varies this year. I think it begins on December 4th, and it is a celebration of computing and specifically teaching in classrooms. It is a great opportunity if you're paying attention to what's going on in your local schools to try and get involved, to volunteer and help out. The tech sector has been really involved. Co.org has been the largest advocate, supplier of curriculum, and really just presence in the space. And then more details here. So, bringing it back to New York. Why does this matter? I mean, when we hear about new Computer Science for All initiatives, typically the conversation is about economics. It's the thing that persuades people to come to the table. We hear that the technology sector is one of the fastest growing sectors for the workforce, that it pays the highest salaries. We've heard that there are more than 500,000 unfilled tech jobs across the country right now via the Bureau of Labor Statistics, and that more than half of future STEM jobs are going to be in computing. So that's very compelling unto itself. But we also know that only 40% of kids have access to CS in school nationally, and that's probably a generous estimation based on what people define computer science to be. Often there are these over definitions. And we also know that very few students voluntarily choose to go into these courses unless they've had early experiences and encouragement. There's a lot of kids who really just drop out of the pipeline because they form an identity that says, this is not really for me. And so the logical conclusion is we should give computer science to more kids and we should start earlier. And in recent years, the idea that computer science for all could be a K-12 thing has really taken root, which is exciting. So I wanted to just, before I move on and tell you more, I wanted to actually let you hear from some kids. They're not here right now, so I have video recordings that we made. This photograph is of the first graduating class of the Academy for Software Engineering. That's a new public New York City high school on Irving Place that we helped start with the New York City Department of Ed in 2012. So their first graduating class is 2016 this year. this past year. This school is important because it was our first flag in the ground that you could teach computer science to all kids who came in the door. It wasn't, you don't have to have an exam score or prerequisite that got you into the building, and that they would work with you and build a curriculum and experience that would give kids a serious multi-year sequence of computer science for everybody. And then 2-3 years later, the citywide initiative was based on schools like that and a myriad of programs that we help support and others that show that you could train teachers from other backgrounds, teachers from literally art, social studies, English, math and science, of course, and really empower them, give them curriculum, give them support, leverage what they already know about teaching, and make that come alive in their classrooms. We're not necessarily making computer scientists, we're making teachers who can really teach something meaningful, do an activity that really engages kids and teaches them the fundamentals at scale. And so schools like this, being able to do a school like this, we opened this in 2012, and the Bronx Academy for Software Engineering a year later. These are the flagship schools of sorts, but there's still 1,500 schools in the city plus. And so how we turn models like this into something that can extend broadly is really the name of the game. So when you look at these videos I'm going to show you, you can listen to the kids, what they talk about, but you can also hear what the teachers, the administrators, the guidance counselors have to say about them.
Before I came to AFC, I didn't have any knowledge of computer science, but I've always been interested in computers and how they work. My parents came from China, and I was born here. They didn't have a college career. My dad works at a laundromat, and my mom is a housekeeper at a hotel. My dad, when he was younger, he used to work at a factory where he fixed machines, and I kind of got that from him.
我細細個咧，我自己都好喜歡係做關於電子嘅嘢，即係 electronic 啊，其他嗰啲，所以我喺香港我都有讀呢啲電子啊，讀嗰啲 electronic 啊呢啲咁樣。至於點解我Carmen 咧，我都好想Carmen去做翻，即係我自己未完成我自己嗰啲電子啊，所以我都好希望佢繼續去讀呢啲關於電腦啊程式關於有啲呢方面 technician 嘅呢方面嘅工作咁樣。
Carmen is a young woman in my advisory who I've gotten to know over the past 4 years. She was always a good student, but the big thing for Carmen was she was so quiet that for her entire 9th grade year, she never said a word, even in our small group setting.
The summer before her junior year, she applied to be an intern at Morgan Stanley. When she came out of that summer, she was a completely different student. She talked to me in the halls, she talked to other adults.
My dream job is become a software engineer. Yeah, like work in the big companies like Google or Facebook.
I knew there was something about technology that kind of called me. I'm from Manhattan on the Upper West Side. I grew up in an okay neighborhood.
Well, I decided to come to AFC because I was really into technology.
I definitely think this is a different kind of school, revolutionary school, bringing coding to students of all different cultures.
I think with Luna, the progression has been in confidence, right? And in fun. She was always the kid who sat in the front of the class with her eyes on the teacher, with a pen in her hand and paper to take notes. And like everything you were saying, she was recording both in her brain and on paper. We've seen her grow from a quiet but focused student to our school mascot, right?
I think being a woman, especially in technology, especially because in the media you don't see much of that. So you think, I'm a woman, I maybe don't fit in that area, let me just stay out of that. I think I go against the stereotype and I can be a role model to young girls like me.
What I'm excited for Luna is that Luna really takes advantage of opportunities. I also think you've gotten better at creating relationships. Like, remember when you were on the basketball team and you told me like they were like, she's so quiet, she like works so hard, but she's so quiet.
While I don't know exactly what, the future holds for me, I definitely see myself, working at huge companies and really trying to get more women involved. I'm pretty sure a lot of us want a certain lifestyle. We dream of maybe living in a house, I don't know, being rich, I guess. But what I want to be is, informed.
That gets me every time. I want to be informed. So these are just two stories. There are a lot of them. You probably heard some commonalities between those two young women that we chose, and obviously this is focusing on high school when we now have a K-12 spectrum to draw from. But this was, for me, this is a lead into a story about visions, because when we talk to school districts around the country, now that New York is underway, we're helping other districts think about this stuff, and that people bring a lot of different ideas about what computer science is for to the table. Maybe you heard some of them in what these young women just said. I want to talk about some research really briefly that some colleagues of ours at NYU and the CUNY Grad Center put together. So a computer science education vision is, it's an argument and a rationale. It's also what impact do you expect to have from it, and also what's the approach you need to take for it. So when we bring people together, they create statements like this: we should teach CS because we need more software engineers. That would be nice, but that's actually not the reason that most of us are involved in CS4All. But that's in the category of economic and workforce development. That's an important bucket. You also hear that it's because kids just need to know how the digital world works. Everything we touch now involves software in some way. It's really hard to avoid it, actually. And so the kids need to know how to participate in a society where technology matters, and you need to be able to make decisions or understand what things like encryption and privacy are all about. We should teach CS because it teaches systems thinking. They believe that there are higher order or generalizable skills that come out of understanding how to program a computer and how it works. So those are in the category of just fundamental literacies for kids. Or we should teach CS because it will introduce a project-based learning approach into schools, which is actually one of the nice byproducts of computer science, that typically classrooms are not a teacher just telling kids what to do and having kind of that rote learning relationship, but actually just giving kids problems and activities to solve and having them go figure it out alone or together in groups. We should teach CS because it will even the playing field for underrepresented students. This is very much why we're doing this work. This is purely a social justice imperative where we give kids access. And so that is a strong driver in almost every conversation we have, especially in New York, though. We should teach CS because the more people who learn CS, the more we will benefit as a society from their knowledge and innovations. One of the teachers that I know likes to tell his kids, like, what if, he's a white guy like me, likes to say, what if all the music in the world was produced by people who look like me? That would be really sad. And I think we're leaving an enormous amount of talent and innovation and ideas on the table when we only include a small number of people. So that's another category altogether. We should also teach CS because it's fun. Frankly, we see in schools when we give kids access to computer science, it's the class they want to go to. They have fun, they get to play with Arduinos, they get to make a movie in Scratch. There's a lot of really fun things you can do, and that education, while it's about learning, it's also about building a level of engagement and inspiration that will actually carry you through learning that you need to do for the rest of your life. So anything we can do there to create opportunities for joy and fulfillment are key. So right there, I just gave 7 kind of major categories of expectations or hopes that people have when they come into the CS4All world. Sometimes they cross more than one category, and that's okay too. Solving problems in their community. When you go to a middle school and you want to get kids excited about something, ask them to think of the problems that they want to solve in their community and then give them a space in which to go figure out how to make that better. Okay. Moving on. So how do we do this? This is a thing that's actually being operationalized all over the country. I'll use New York City as an example because we're the biggest and we're a little bit ahead. So we're bringing, in the next 10 years, by 2025, creating an operation that will actually reach about 240,000 students per year across the school system. We're not requiring every kid to take computer science every year, but in every grade band, K2, 3, 5, 6, 8, and 9, 12, every kid will be required to have some kind of meaningful learning experience that's defined by the substance of what they do, making an artifact, being able to talk about how they created it, and sharing why it's important. We're training 5,000 teachers to do this. This is not a hardware buying thing. It's not a curriculum buying thing. It's all about getting teachers into learning spaces and supporting them so that they can then go do something meaningful in their own classrooms. And this is there's a big team at the New York City Department of Ed now, about 20 people, both centrally and out in the boroughs. We have people in all 5 boroughs supporting schools to learn how to do this and making sure that they're doing what's right for their own school. Every school is different, and their needs are different. They're serving different goals for their populations. They might have 40 languages spoken in their school, lots of English language learners, or they might have a high special education population. And so the teachers in the building and their principals know how to serve this population, and so it's a work in progress as we bring computer science in and help them figure out what's gonna work best for them. The team at the DOE offers a variety of inroads, from an introductory, a couple days in a classroom for a teacher that they can then turn into a unit of sorts, and then building up to full courses or sequences of courses that are taught over multiple years in elementary, middle, and high school. So the idea is that you have a high end of the curve where you've got kids doing something that's really immersive and serious, and then you also have just lots of exposure and opportunities to engage across the disciplines, which is also really exciting. So I said earlier that you have to build on teachers' expertise. Like, we can't just retrofit the school system with a completely new curriculum area. We've seen innovation like that fail over and over and over again. It's pretty easy to learn from that and just embrace the fact that this is a messy, community-based process. And teachers know how to reach their own kids. Also, you're building a workforce that needs access to each other. We started a meetup community called the NYC Education Meetup 4 years ago. It started in a bar with about 30 people, and now we have about 2,000 people in the meetup, and we run monthly meetups for them to see each other during the year. And the DOE now has opportunities for those folks to connect all the time. You also need to get your experienced CS teachers out in front so that they're mentoring and supporting teachers who are coming in. Meg Ray, who is a member of this community, is one of the co-facilitators of the Young Coders Initiative here at Pi Gotham, and you should go meet her. She's based now at Cornell Tech, which actually has a formal CS coaching program, and she works in many schools across the city. Lastly, I wanted to talk about the national stuff, just because it's cool. So last year in September, we launched an initiative called the CSforAll Consortium at the White House, the old White House. It was what was exciting about that was that as a national community, we had a huge number of people doing work that was disconnected, and it was time to bring it all together under one roof. And so we have content and curriculum providers, trainers of teachers, funders, corporations, researchers, everybody under one roof, school districts from every state. And we are a hub that's meant to connect them all, support them, and give them access to each other so that nobody has to enter this space without any guidance or support. My title, I want to go back to the title of this talk before I run out of time, which I may already have. The title of this talk includes the words rigor, inclusion, and sustainability. When we were trying to define what the CS4All movement, it was a hashtag. then it became kind of a movement, and now it's a thing. It's a thing in cities. It's a national coalition. We should declare a purpose and some values for ourselves. And so these are the three that we arrived at. Rigor means it's more than engagement, that we need to actually have students do meaningful CS that looks like CS and not give up on things that are hard, but to really stick with it. And we also need to create pathways so that kids are connecting this to everything else they're learning. And as they go through a K-12 sequence, it's not just repeating if statements over and over again. They're actually doing things year after year that build and get them to a new place. Inclusion. This is important. All students should learn computer science. This is something we believe in. And we also believe that all students can be successful. And that is something that is the work. This is the hard work that happens every day out of view. And then sustainability. This is, education innovation comes and goes. We don't want to be that. This is actually a fundamental change to the curriculum that's being taught in schools. That doesn't happen very much. In fact, I can't really think of the last time there was a massive introduction like this. And so this is a long-term systems change. We gave ourselves 10 years to do this in New York, not just because there's a lot of schools to get to, although that's one of the reasons, but because this is something that we expect is actually going to take that long and longer to figure out. What can I do to help? These are two excellent organizations that both have, ScriptEd is based in New York City, and TEALS is a Microsoft initiative all over the country that has a strong New York City presence. Hopefully you've heard of these. Both of them are opportunities to volunteer in schools. You can teach kids, you can teach side by side with teachers, you can run your own thing. And both of these organizations are notable because they provide a ton of support. So even if you've never taught before, they're a great on-ramp. While their websites are here too, I can also, perhaps there's a way for me to help facilitate introductions there if you're interested in this. Are any of you volunteering for either of these organizations right now? One. All right, awesome. I hope next year I'm gonna come back and I hope all of you raise your hands. Also, we're doing a summit next, a week from Monday and Tuesday that is a 1-year anniversary of our launch to mark the progress we've made as a country and to celebrate new commitments. It will be live streamed if you can't get to St. Louis. Here's the website. I wanted to leave you with a little audio clip from we did a phone call last week, 2 weeks ago.
I strongly believe every child has to have the opportunity to learn this critical skill. It's becoming fundamental, just like reading and writing and math. We are inundated with technology, and I don't want our young people to just be consumers. I want them to be producers of this technology and to understand it, to feel that they're controlling it as opposed to it controlling them. And I know there are a lot of young people at school listening today. I want you guys to know how proud I am of all of you, how much I believe in you, and I can't wait to see the amazing things that you're going to build. Computer science is changing virtually every industry, from manufacturing to health. And I want to make sure that our young people learn it so you can be in the driver's seat. To be active citizens in our society, you've got to understand how technology works under the hood. So I could not be prouder of the work that all of you are doing. The fact that you are keeping it going and have maintained momentum is something that I couldn't be more grateful for. And as you do this important work, just remember to keep inclusion and rigor and sustainability in your sights. Those things aren't contradictory. Complementary.
Welcome, everyone. This is Ruth.
All right. All right, that's my last statement. President Obama is still around, and he, CS4All was, while it was announced, while he made a big announcement about this in January of 16, this is a community movement. It lives on. It predates that administration. It will continue. And I just wanted you to know where we are today and where we're going. Thanks very much. I think I'm out of time, but I'm happy to take questions if there is another moment. Is there someone who has a point of view on that?
Yeah, go for it.
Okay. Yes.
curricula are already pretty stuffed, aren't they? What do you face in terms of people saying, well, what are we supposed to take out to put this in?
That's a great question. The question was, with so much, I think your question is also about how much is just happening in schools generally, that schools are so much in their schedule, requirements and things they have to do, where do you fit computer science? That is the big question, and this is where the flexibility for schools comes in, where high schools, for example, can prioritize computer science. They can make it the technology course that kids take instead of learning how to do like the digital literacy or productivity kind of stuff that they might be already doing. It just could be switched out. But for the kind of long tail of adoption, I think there's room for meaningful integration with other subject areas where computing has its own place as a fundamental skill set that needs to be taught explicitly, but that it actually becomes quite fun when it actually is mobilized to make beautiful pieces of art. You know, how would you visualize all these data, for example, or where I mentioned the Bootstrap curriculum, for example, is actually a 20-hour algebra unit that can replace the existing algebra unit, achieve the same goals, and also teach kids some functional programming that makes a neat video game in the process. So there's a lot of room for that. Yes?
Thanks for your presentation. I think your work is really important. I have some feedback for you. Would you like it now or afterwards?
How is it bigger than a bread box? Is it, well, if you want to make a comment, sure, and I can relay it back to the room, and then if we can talk later.
Like when we were talking about diversity of New York schools,
Mm-hmm.
so that it was half girls, half boys.
Mm-hmm.
And I want to mention there's like a lot of non-binary kids in New York City,
Mm-hmm.
especially because there's shelters where
Yep.
come to New York especially.
Yep. Thank you for that comment. Yes. So while we report data from the school system in a gender binary way, obviously that is not necessarily representative of the kids. And I don't think the DOE actually tracks that well. But I will go back and look for that and make sure that I'm actually correct when I say that. Thank you for that comment. Any other questions? Okay.
All right, let's give
Thank you. Thank you.